Well, if you watched my other videos on building a Cylon project, you'll know that I came up with this crazy idea to add an accelerometer to the project. And this is the board that I end up coming up with. And I have to stress that this is a prototype board. If you build this, it's going to look slightly different, but it's going to be so close that you're not going to have any trouble with it. Basically, a different pinout here so that I could use more than one type of accelerometer. Speaking of accelerometers, here's a couple of them. This is a 3G accelerometer. This is a 20G accelerometer. And the one I end up using, I only have one. It's already in the other board, but it's another 3G accelerometer. So I tried several different ones because they range in price from $4 to $15. So I try to get the one that's going to be the cheapest. Now the components on this board, I'm not going to really go through them. I'm not going to show you how I installed them and things, because if you go to my website, if you've done any of my other projects, you know that I have pretty comprehensive data on the website at rv-project.com that explains, all the parts and parts list and all that stuff so that you can insert all the parts. This video is going to be long enough as it is, and so I don't really want to make it any longer than needed. Now, there's one thing I need to point out, though, is these three parts here. This is kind of experimental, and in the instructions I'm not going to cover this, but just realize that I put these on here for experimental. Somewhere down the road it might be worth going to the website and see if I've done anything with this, but I'll explain what it is as we go on. And I designed this board to fit into this case. Now this is kind of a generic made in China case, and it's a extruded aluminum case. There's no part number on it. The only way to identify it is that it's an 80 millimeter by 23 millimeter by 90 millimeter wall mount aluminum closure. So if you use those search terms on eBay, you should be able to find the case that I used. And the way that it works is it just simply slides in here, and this board is, I have not trimmed it yet, so it won't slide in, but I assure you that it will. And then I had two ends made. This is one end that I had made in Front Panel Express, and I have to tell you, it is a little bit expensive to go this route. And if you go to my website, again, if you've done any of my projects, you know that I have templates for this. Well, you can download a template, and you can actually print the template out on the printer, and it'll be life size. So you could take the end panels that the case comes with and just put the piece of paper over that you printed, and then just drill the holes out, and it'll be a whole lot cheaper. And here's the assembled board, and this one, just to show you that it fits, it just slides in there like that. And then this is designed to mount in one of several different orientations. Here's the populated board. We have the power supply section here. We have a fuse here. Now this fuse is soldered in, and so if it blows, you're going to have to basically unsolder it and put another one in. And if you don't want the fuse, you could just jump her across if you wanted to. Now these, I told you, are experimental, and I'm not really going to want to have you put these in because I have not fully tested this. But these are low voltage MOVs, and what they do is they basically protect the Cylon eye cabling between here and the Cylon eye against things like power surges and lightning strikes that are nearby and things. I don't know if it's necessary yet, but it's just something I'm experimenting with. And then here we have two potentiometers. This is for the accelerometer, which is here. And this is a coarse adjust, and this is a fine adjust. Now the coarse adjust, you have to adjust with this board out of the case. With a fine adjust, I've put a hole in the case so that you can run a screwdriver in here and adjust it when it's in the case. Then again, here's the AT-Tiny85, the CPU. And this rotary switch is used to tell the CPU which mode to be in. And there are 5 modes. The hitch light, which is all white lights. Then the next mode is the level, which is the accelerometer. And then we have the Cylon eye, and then the marquee, and then the rainbow effect. Now, I've always said this is kind of silly. However, I was camping the other day and I noticed that somebody had a bucket draped over their pin box on their fifth wheel with a light in it. It was there so that you don't run into it at night. So in reality, this is not superfluous at all, because when it's in the Cylon I mode or any of those other light modes, it basically provides a clearance so that you don't smack into it at night. Alright, so then that goes to the rotary switch, and then again, this is the accelerometer. Now, this accelerometer, these are all based on the ADXL 335, although I do have an update on this one. This is a 337. And I've tested all three of these accelerometers. And I'll put the 3 accelerometers on the parts list so you can choose any one you want. This one is from Adafruit, and it has about a plus and minus 2.5 degree range. When you look at the 9 LEDs here, when this LED is on, it's 2.5 degrees to 3 degrees one way, and then when this LED is on, it's 2.5 to 3 degrees the other way. Now this one is about 16, 17 bucks, which is kind of expensive. This one is plus or minus 4 degrees, so it's not quite as sensitive as this, but it's 4 bucks. Or 3 bucks, something like that. This one is around $5, and it's also plus minus 3 to 3.5. So they're all within the same range. So it depends on which board you buy, how much it's going to cost you. Now in the program, which I'll cover in another video, you can detune this. So if plus or minus 3 degrees is too sensitive, you can go to 6 degrees or whatever, but 3 degrees is about as most sensitive as you can get. And there's also some shorting pins here, like you might see in computers. There's one for X, one for Y, and one for Z, because again, this is a 3-axis accelerometer. You only want to short one of these, X, Y, or Z. Now the X-axis is this way, the Y-axis is this way, and the Z-axis is this way. So I'm going to mount this upside down, and it's going to go like this when the tilt of the RV. So I want to use the X-axis. But say you mounted it on the wall like this, and then with a tilt like that, you want to use the Y-axis. You're only going to use one of these three, but this allows you to choose which axis you want to use. So you can virtually mount this box here, these mounting screws, you can virtually mount it anywhere. And we've got a tilt direction, and when this is shorted out, the direction is one way, and then when it's open, the direction is the other way. When we tilt this like this, you can have it go this way, or you can have it go this way, the LEDs. The first thing we want to do is we want to calibrate this thing coarse. So we're going to plug our cable in, and you're going to want to have this in the proper orientation of where you're going to mount it. So turn power on. What we want to do is we want to get as flat as we can, and we want to adjust this just somewhere like that. It could be anywhere along this line, but we want to get it as close as we can to centered. Now we'll turn power off and we'll put it in the box, and then we'll see how it works. Okay, we got it in the case, turn it back on, and we've got this blinking showing us at one end. So what I'm doing is I'm going to take my adjuster, and you can see this is pretty sensitive here. Okay, see as I'm adjusting this, turn it back a little bit, see how we can center it. And by the way, green is center. Okay, if it's static, and what I mean by that is if the reading hasn't changed since the last time, and it measures this about twice a second, it will not blink. But if you go from one, see how it blinks once and goes steady? We go back, it blinks once and goes steady. And see, as I keep tilting it, it goes farther and farther over. And then if you keep going and it blinks faster like that, that means it's out of range. That means if there was LEDs out here, it would actually go on those. And then again, we can go the other way as we tilt like that. Now what I mean by the tilt angle, you notice that when I tilt it this way, that it goes down to that. So as I go in a clockwise direction, this goes from left to right, and I go in a counterclockwise direction, it goes from right to left. So if you mounted this upside down, then it's just going to be the opposite. If I go in a clockwise direction, it's going to go right to left, and if I go in a counterclock, it's going to go right to left. And that is what that little one jumper is for, so you can change the orientation. So depending on and also if you mount this upside down like that, you see it'll change as well. So depending on where you mount this, right side up or upside down, and if you mount this way or this way, then you may have to put that little jumper in or out, depending on which way you want the LEDs to go. All right, and then we all have still the other functions. We here have the hitch light, the leveler, the Cylon, the marquee, and then the rainbow. So all the functionality of the other ones are in there, but we have added an accelerometer to this one. We have a camping trip in a couple weeks. I'm going to install it, and then we'll do a field test video. But this just kind of gives you an idea of how this accelerometer version will work. Now there's also an LED here for the 5 volts, and I put that in just because if the fuse blows, that will be off. And this new circuit board, the difference is this one here is designed only for the Adafruit accelerometer, and the new circuit board is going to have another set of pins here, so you can use one of these other accelerometers if you want. So the new board will handle 2 different accelerometers, while this one only handles the one. So again, go to the website if you need some more information. I'll have everything there so that you can build this.